Alright, so I look at this one, and what I'm probably going to do is I'm probably going to leave this side alone because it's in terms of cosines. Okay? And there's not really much I can do with it. There would be one little trick in which we multiply by conjugates, okay, which I'll show you later on. But I find it a lot easier to take the sides that are not in terms of sines and cosines and turn them into sines and cosines. Because if I can make everything be sines and cosines, the world's just easier. Okay? So that's why when I look at this, I'm probably going to mess with this side here. Okay? What does it mean to square something?
Take it times itself.
Take it times itself, right? So I'm going to write out my steps here. I would probably just mentally do a FOIL right here, but I'm going to show my steps. All right? So cosecant x minus cotangent x times itself. Cosecant x minus cotangent x. Right? Because that's what it means to square something. Take it times itself, right? And now I'm going to FOIL. Right? Cosecant times cosecant is cosecant squared. Cosecant times a negative cotangent would be a negative cosecant cotangent. Then negative cotangent times cosecant would be another one of these. So negative cosecant cotangent. And then negative cotangent times negative cotangent would be a positive cotangent squared. Any questions on the FOIL? On the distributing there? Everybody see it all right? Okay. Cosecant squared and cotangent squared, do they exist in a Pythagorean identity somewhere?
No.
They're not together anywhere in one of those Pythagorean identities?
Wait, yeah, they are.
What's that Pythagorean identity
1
say?
plus cotangent squared equals cosecant squared.
Oh, so there it's not quite there. You said 1 plus cotangent squared
Equals cosecant.
equals cosecant squared?
Yeah.
So I never really have a cosecant plus a cotangent, do I?
No.
Okay. So that was my first thought, is try to use a Pythagorean identity. But because if it said cosecant squared minus cotangent squared, then I could have replaced that with a 1, right?
Yep.
Okay. I'm going to put everything in terms of sines and cosines now. And let's just see once what happens. Cosecant squared is really what? 1 over sine squared? But are you guys hearing my thought process here a little bit? Because I don't know for sure quite where I'm going with that. I think I might see it now, but cosecant is
1 over sine.
1 over sine. Cotangent is
1 over
cosine over sine. Same thing again, right? 1 over sine. Cosine over sine. Plus, and then cotangent squared would be cosine squared over sine squared. Ooh, I'm kind of liking this now. Why am I liking this? What am I maybe seeing here?
Yeah.
Got a bunch of common denominators,
Yep.
bunch of sine squareds on the bottom. So hopefully that'll help here a little bit. So 1 over sine squared minus cosine over sine squared minus cosine over sine squared plus cosine squared over sine squared. You guys will love this one.
Can you cancel out?
Can't cancel because we're not multiplying, but I could write this as a single fraction now. Okay? They're all over sine squared. So I can do 1 minus cosine x plus cosine squared x. These are like terms. So I'll have 1 minus 2 cosine x plus cosine squared x. Right? Because 1 minus cosine x plus cosine squared would give me 1 minus 2 cosine x plus cosine squared x. I can write it as a single fraction. Are we seeing this? I just added or subtracted the numerators together. Okay? Alright. Look at what we want to get to. All cosines, right? I got this sine squared sitting here. Can I replace sine squared with something that is in terms of cosine squared? Look at your identities. What would sine squared equal? It's not plain as day, but some of you should be able to manipulate one of those.
Cosine squared.
Well, sine squared would equal 1 minus cosine squared.
Yeah.
Okay? So I'm going to replace this with 1 minus cosine squared. For those of you that didn't look back at your identities, one of your identities says sine squared plus cosine squared equals 1, right? So if I subtract cosine squared to the other side, do you see how sine squared is really equal to 1 minus cosine squared? So that's what I'm going to replace this with right now, is 1 minus cosine squared, because I want to get everything into terms of cosine, because that's where I'm headed with this thing. Okay? Any ideas right now?
This goes on.
We have to get rid of the squares.
Yes. How? Got it. Any ideas?
Can you write them out on top and then cross them off?
What do you mean?
Tricky.
What? Say it again.
I'll like write them all out and then like cross them off on top and bottom.
In order to cross them off on top and bottom, I'm going to have to do what? You have to have common factors.
Oh, we have to factor now.
You have to factor.
Oh my god.
You have to factor now. Remember all that factoring you had to do in Algebra 2?
Oh, you mean the one that like...
I mean the one that was.
This is where you have to factor. Okay?
Factoring don't know where.
Factory? Don't know.
Okay? Quick refresher. Okay? On some factoring. Okay? What multiplies to x squared? X and x. What two numbers multiply
63.
to positive 12 but add to a negative 7?
3 and 4.
Negative 3 and negative 4? Recall that?
Yeah.
Okay, if you multiply it, if you would distribute it back out, you get x squared minus 4x minus 3x plus 12, which is what you started with. Okay? X squared minus x minus 20. X and x. What multiplies to negative 20 and adds to negative 1?
20 and 1. 10 and negative 10.
They don't add to negative 1.
Negative.
They gotta add negative 5 with a positive 4. Do those multiply to negative 20?
Yeah.
And do they add to negative 1?
Yeah.
Yep. Okay? Or you had a special factoring rule for this, the difference of two squares. Or another way to think of it is, isn't this like saying x squared plus 0x minus 36? So what multiplies to negative 36 and adds to 0? Positive and negative 6, right? So x plus 6, x minus 6. That's the difference of two perfect squares. Anytime you have two perfect squares, you can factor it this way. So if I had, like 4x squared minus 169. Those are both perfect squares. 2x plus 13 and 2x minus 13. 2x times 2x gives you the 4x squared, a positive 13 times the negative 13 gives you the negative 169. Those are the difference of two perfect squares. Okay? All that factoring is going to start coming back here a little bit. Okay? So now, knowing that, if you look at the bottom, since I just talked about this, if you looked at the bottom, 1 minus cosine squared, are those both perfect squares?
Yeah.
Sure they are. So what would the two factors be at the bottom?
1 plus
Plus cosine x and 1 minus cosine x. Now the top, it's a trinomial, okay, so it's going to be factored much more like these right up here.
I got that. I did.
What times what equals 1?
1.
1. And then what will multiply to a positive cosine squared and add to a negative 2 cosine x?
1 cosine. Or just cosine. X.
Are they positive or negative? They got to multiply to a positive cosine squared and add to a negative 2.
Both negative.
Both negative. Now what can you do?
No, you can
Cancel. Now you can cancel exactly what you were talking about. Since you are factored now, you have something times something over something times something. Since it's been factored, any common factors you see, okay, one of these will cancel with one of those, and you're left with 1 minus cosine over 1 plus cosine, which is exactly what you wanted. I'll bring it down. How was fun?
I don't know about fun.
Okay, challenging.
Was that one of the harder ones we've done?
Yeah.